I don't think I need to tell anyone that's here at the METS show that we're all operating in a new normal. A new normal for the marine industry, for sure, in almost every segment. And I think a lot of us look at the industry in terms of the global financial crisis being a real marking post for us. And a lot of us look at what was the world like in the marine industry pre-global financial crisis, and what does the world look like in the marine industry post-global financial crisis. That's clearly the case for Mercury, and it's clearly the case for our stern drive and inboard engine segment. And our stern drive and inboard engine segment, which I'm going to talk about today, I'm going to talk about our new marine purpose-built engines. That's an example. It's an area of our company that, as you could say, pre-global financial crisis was always based on an automotive engine. All of our engines in that segment and in the entire industry were based on an automotive derivative engine. But over time, and specifically in the recent few years, there's been a divergence between the automotive industry needs and direction and the marine industry needs and direction, and we've come to a breaking point in our view. And as those customer and regulatory requirements for marine and automotive propulsion have continued to diverge, Mercury has made a decision to take control of our own destiny by developing and manufacturing purpose-built marine engine platforms in the stern drive and inboard segment. So, automotive engine technology development is now dominated by the requirements to achieve future CAFE regulations. So CAFE regulations are all based on emissions and fuel economy. CAFE stands for Corporate Average Fuel Economy. And achieving these standards requires implementation of multiple, complex, and expensive technologies, which is really irrespective of their true customer value. So the automotive industry really has to do what they're doing to meet CAFE regulations first and foremost before anything else. And many of these technologies have low real value, even on low speed, light automotive operating cycles. And for marine applications, where the duty cycles require operation at higher engine speed and very high torque, as we all know, the fuel economy impact is even minimized. And so in other words, the level of technology achieved in automotive translates into significant complexity with very little value in a marine application. So I'll give you an example. In CAFE standards today, 2014, light trucks need to meet, on average, in your fleet, 32 miles per gallon. By 2025, they'll have to meet 50 miles per gallon. So they will go up year over year by 1 to 2 miles per gallon per year. What that's doing is it's shortening the life cycle and expected that the automotive industry is planning for each engine that they put into place. So as an example, in the marine industry, in 2012, a 6-liter Generation 4 engine was introduced. That engine will be discontinued by General Motors in July of 2015, just 2.5 years after its introduction. That type of hyper product development that the automotive industry is going through for very, very good reason translates into very high cost for the marine industry as the marine industry chases that cycle to try to marinize those engines and turn them into robust marine engines. We've also moved, the automotive industry has also moved to aluminum engines, which they have to do for all good reason to take weight out of the engine. They've got to do everything they can to take weight out of an automobile, and that starts with the engine. But there's a high copper aluminum automotive alloy that does not provide adequate corrosion barrier to the harsh marine environment. Low copper alloys for castings are critical for being able to deliver superior corrosion performance in all marine environments. For corrosion properties, copper is one of the most corrosive elements that can be found in an aluminum alloy. So as the automotive industry moves to aluminum product, aluminum blocks, aluminum cylinder heads, aluminum exhaust manifolds, we saw this as a non-starter just because of the corrosive properties of high copper content aluminum. Hull modifications. New aluminum engines are significantly wider and taller than current cast iron blocks and General Motors cast iron blocks, and that requires significant boat hull design modifications. So a Generation 5 V6 GM engine is 122 millimeters wider and 109 millimeters taller than the engine that it's replacing. That can be very disruptive to all the boat builders that are in the world. There's also durability and reliability concerns with some of the developments of the automotive industry as it translates to marine. Not for automotive, but for marine. So you're taking a reduced displacement engine, and at a high revving engines in marine, you have durability concerns. So the marine engine manufacturers were really forced to provide costlier engines that are designed for automobiles or create a marine appropriate alternative. Now let me just talk about, very briefly, an equation that we use at Mercury quite frequently. And this is a very basic equation that's applicable to the marine industry, and I suppose you could apply it to any consumer product. And it's basically that the boating benefit that a consumer enjoys minus the boating costs, and those boating costs are behavioral costs in terms of time and effort that are associated with boating, and it's also economic costs, how much money it costs to acquire a product and to use a product. You take the benefits, you subtract the cost, you get the overall boating value. And so as we set out to develop a new marine purpose-built engine, understanding that the automotive engines that are going to be in the market tomorrow are not right for marine, we said we're going to make a marine-specific engine. We have to impact this equation. We've got to impact this equation both on the boating benefit side and on the boating cost side. So I'm going to talk to you a little bit about what we've done to enhance the overall equation, which is right for the industry. We want this equation to be as positive as it possibly can be. So in light of the changes in the automotive industry, Mercury chose to develop we started with a 4.5-liter V6 engine platform. It delivers the highest value, we believe, in marine applications. With its marine-specific platform, we have been able to focus on designs that really benefit marine operations such as low friction, large displacement, efficient air handling, and select new technologies that really do provide these meaningful benefits. We've developed an engine from the ground up, from a clean sheet of paper, so to speak, and we're optimizing each component and the system to deliver the best boating experience without the constraints of an automotive engine architecture. So the product, the purpose-built Mercury 4.5-liter stern drive is aligned with our marine customer needs. That's OEM boat builders, dealers, distributors, and consumers. We're really focused on the voice of the customer here. So the controls, we control product life cycle pace, as I talked about, as opposed to it being controlled by the automotive industry, and that really helps control cost. We have a common V6 and V8 platform with component design. Each engine design is optimized for the marine industry. We leverage our OEM and our dealer investment and infrastructure that was critical to us to be good partners. And we have the same dimensions as our current engine platform because we did not want to be disruptive to the boat building industry around the world. So the new Mercury 4.5-liter, 250 horsepower engine What are the attributes of true customer value? So what am I talking about? When we do voice of the research, what do we see customers really telling us they need to have and they want to have in their propulsion system? They want a simple engine design with high technology and value features that deliver things like quick acceleration. Quick acceleration is critical to boaters. Getting up on plane fast. Best noise, vibration, and handling, and the throttle and shift experience. Noise, vibration, and handling are really critical to consumers. People don't want to hear their engine when they're on the boat, whether it's idling or they're at cruise speed. They don't want it to be disruptive to them. The throttle and shift experience and how we design the flywheel is really important to a consumer in terms of the feel of the product as they interact with it. They need it to be easy to maintain, not cumbersome to maintain, but easy, intuitive to maintain, simple and straightforward. They need it to be durable and very corrosive resistant, and they want improved cruise fuel economy. So that's what we're delivering. So it's a marine design. It's reliable, durable, intuitive, and powerful. It's a V8 in a V6 body, so it's more engine for your money when you really get right down to it. We have new features like adaptive speed control, and let me talk about this, and in a minute I'll talk about how we brought this to fruition. So it's better drivability. What this means is better drivability of the boat. Remember that equation. Boating benefit minus boating costs equals the value that any consumer gets, and every consumer is different. This is driving the benefit side, making boating more enjoyable. So adaptive speed control automatically maintains the set RPM that point that you want to set your RPMs at. And that's regardless of load or conditions as they change on the water. So if you do a tight turn, your load is obviously changing. The engine will maintain the constant RPM to give you much smoother drivability of the boat. Tow sports is another example where this is applicable. And lower speeds on plane. This is really applicable to have lower speeds and stay up on plane. This gives a sportier feel for the driver, and you no longer need to make throttle adjustments. It just makes it easier and more enjoyable to drive your boat. It's driving that benefit side of the equation. Smooth and quiet. I talked about why that smooth and quiet in our consumer research is really critical to any boater. They want it to be smooth, quiet, something that they can interact and not be encumbered by the noise and the vibration of the engine. We've taken and we've done that through a rear-facing throttle body, through an anti-whistle throttle plate. The engine cover and mounts are critical for noise, vibration, and harshness. A light flywheel so you don't have a clunky feel when you're shifting. It's really smooth. A fuel supply module and a structural oil pan. All of those work together to provide superior idle and superior smoothness as well as noise and vibration. It's a better boating experience. It's driving the benefit higher of being a boater. Easiest maintenance. Consumers want intuitive maintenance. They want it to be simple and straightforward. We paid particular attention to the ease of maintenance. We've eliminated the need for a traditional 20-hour service point. We've got a maintenance center that's near the front section. So as you can see, just up there, that ensures the consumer's touch points. It makes it simple for them. Simple things like an oil filter and the oil fill are easily identifiable and they're really easy to access. The valve train is maintenance-free for life. There's a QR code on every engine, and that allows smartphone users, which we all are today, to scan that QR code, and they can easily get a how-to video on anything they might need to know about their engine or anything they might need to service on their engine. Tells them exactly how to do it. You could have a teenager go and service your engine. It makes it that simple. So how did we do it? A little bit more detail about how we did this. I talked about the changing dynamics in the automotive industry already, that driven by the CAFE and fuel efficiency, and emission standards, General Motors actually announced in 2012 that it will replace all of its offering of marine and industrial engines with more expensive on-highway technology, the aluminum engine. So we have a GM base engine and a 3-liter, a 4.3-liter, a 5-liter, a 5.7, a 6.2, and an 8.1. 2012, GM said they're all going away. They're all going to be replaced with the aluminum engine technology. That's right for General Motors. They have to do that. They've got to meet CAFE regulations. It's not right for the marine industry, as we have determined that we've got a better avenue that we can take. So let me go on. The right technology for the job. So first, the high displacement. In a naturally aspirated engine, displacement, or engine size, is perhaps the single biggest factor in determining how much torque and horsepower the engine will be capable of producing. Higher displacement equals higher torque and greater horsepower. At 4.5 liters, this engine has more than enough displacement to ensure best-in-class acceleration against not only competitive V6 product, but also today's 5-liter V8 class models in the marketplace. So the V6 that we've just come out with will perform better than today's 5.0-liter V8 product. Talking about the intake manifold. We feature a compact, lightweight, what we call scroll intake manifold. The scroll shape is one that allows for packaging longer intake runners from the throttle body to the intake valve by wrapping the runners into a more compact shape. Longer runners provide optimized intake tuning for improved low speed and mid-range airflow. The right technology for the job, a little bit more on this. The new 4.5-liter uses a combination of cast iron, composites, and aluminum for best combination of durability, corrosion resistance, and lightweight. All of our components that are in direct contact with raw water, that's lake water or seawater, salt water, they're cast iron. Cast iron has very, very low copper content, and that's critical in any anti-corrosive environment that you want to have. So that includes the blocks, the cylinder heads, the crossover, and the exhaust manifold and elbows. That's all cast iron. The intake manifold is aluminum, which helps lower the overall package weight. Now that's based on Mercury's patented aluminum, which is very, very low copper content, versus an automotive aluminum engine, which is very high copper content, and therefore you'd have corrosive concerns in a marine environment. For horizontal engines that are not self-draining, cast iron provides far better long-term corrosion protection, and therefore durability against raw water in the cooling system. So if you have a competitive product that's based on an aluminum, new automotive aluminum block, it requires very expensive closed cooling systems to avoid that corrosive environment and premature failures that are associated with standing raw water in non-treated raw water cooled aluminum cooling passageways. The wide band oxygen sensors that are noted on the top right of this chart. Wide band oxygen sensors pre-catalyst provide optimized closed loop fuel control throughout the operating range. Wide band oxygen sensors allow the ECM to continually fine-tune the fueling. So by monitoring the oxygen pre and post-catalyst, the ECM is able to fine-tune the fueling with higher precision to maximize fuel efficiency for the life of the engine. Highest levels of craftsmanship. Styling is very important to us. So we want it to look and to be simple and robust, linear and uncluttered, intuitively designed, tightly organized, visual layering to the engine, and very, very bold forms. At 4.5 liters, the new Mercury engines have been sized to deliver the torque levels needed for class-leading acceleration while striking a balance for smooth operation. Lightweight, and most importantly, without increasing the package size over the current 4.3 and 4 and 5.0 liter models. We did not want to be disruptive to the boat builder customers that we serve. The new 4.5 liter engines are 940 pounds. That's with an Alpha raw water cooled model. By contrast, the 5 liter, our current 5 liter product, which is a similarly coupled with an Alpha raw water cooled drive, is 1,059 pounds. So that's a reduction of nearly 120 pounds, or 119 pounds, or 11% weight reduction. Lighter weight improves the power-to-weight ratio and fuel efficiency, and also reduces the overall package weight of the boat. So it allows you to take full advantage of the engine's torque for quick acceleration. And remember, quick acceleration is a key consumer value driver. Adaptive speed control. I talked about adaptive speed control. This is a critical feature that improves the enjoyment or the benefit side of that boating equation. Let me talk a little bit more about it. Computer-controlled electronic throttle body responds instantaneously to the operator's input, and in fact will advance the throttle further than requested until the operator's desired speed is reached before bringing back to the point necessary to maintain that speed. That all happens automatically. The adaptive speed control automatically maintains the set RPM. You set the RPMs, it maintains the RPMs, and it's regardless of load and conditions. So when the engine senses an increase in load, such as when the operator is cutting a hard turn, or when he's trying to hold the boat on plane at a very low speed, the engine will automatically apply throttle to maintain the RPM of the engine, without the operator having to make a physical correction to the throttle handle. So holding the RPM during hard turns allows the operator to keep both hands on the steering wheel, which is safer, but it also makes it more sporty and more enjoyable to drive the boat. You really have to experience this feature to appreciate what it does for you at the helm of a boat. And holding a boat on plane at low speeds is useful in windy conditions. It's useful during tow sport activities, or whenever precision boat control is needed without a lot of speed. And with an electronic throttle body, acceleration is significantly more responsive and it's more exciting. Smooth and quiet. I talked about smooth and quiet, or noise, vibration, and harshness being another key consumer value driver. A little bit more about it. The intake opening is a direct conduit into the engine itself, and as such is one of the loudest points on the engine, the air intake. By situating the air intake opening aft, the engine noise is directed away from the boat instead of into the cockpit area. So you're pointing it backwards versus forward into the boat, where the people are conversing. That is our ability to do that is a direct result of not having the constraints of an automotive base engine platform. An anti-whistle throttle plate. As the throttle body opens, the engine vacuum rapidly draws air past the throttle body and into the intake. That airflow forms a pattern which, as we all know, can emit a whistle, a very irritating whistle, especially over periods of time. So we've found a way to deflect that air pattern, and we've eliminated the whistle, making it far quieter and much more pleasing to people in a boat. We've also incorporated a lightweight flywheel, and that generates lower inertia and reduces shift clunk and shock. Our 4.5 liter product incorporates new front and rear engine mounts with a larger overall footprint. Those engine mounts are significantly better at isolating undesirable engine vibration from the rest of the boat so that you don't feel it. We also incorporate a heavy-duty aluminum oil pan versus the prior stamped steel model. And a heavy-duty die-cast aluminum has thicker walls and it's got stamped versus stamped steel. It better absorbs that engine noise and vibration and has improved corrosion protection. And that also allows OEM boat builders to rest the engine on the oil pan during the installation process, something which they've been careful not to do to this point in time. Makes the installation a little bit easier for our customers. We have developed a styled engine cover that has closed cell acoustic foam lining. That acoustic foam is especially effective at blocking engine noise while minimizing water and debris absorption, and it's part of our sound reduction technology. What can be heard is low level and low frequency for a more pleasing overall tone versus competitive products with higher pitched drones that fatigue the operator over time. Quiet, smooth operation makes it easier to converse while in and around the boat, especially on a long day of cruising. So the key takeaways from this are superior idle smoothness, lower operator vibration across the range of speeds, better speech intelligibility at cruising speeds, excellent shift experience, especially with digital throttle and shift, and we've also incorporated our joystick docking option into this product, and it's got smooth shifting with less clunk. Conveniently located decal on the new 4.5 liter provides quick and easy overview of the color-coded service points. So all the service points are color-coded to make them intuitive. Daily and weekly charts, etc., are included. And we've got that QR code, which makes it especially easy for anybody to understand their engine and know what to do and when to do it. Finally, a little bit about our manufacturing. We put in a modern manufacturing system which went into production in August of this year. It is a state-of-the-art power head assembly, floor-mounted conveyance system, complete with robotics, electronic assembly quality controls, advanced training tools for operators at each assembly station. It's in full production on the 250 horsepower, and the 200 horsepower will follow in 2015, as well as a V8 engine model, which will follow in 2015. A view of that assembly station, you see the floor-mounted conveyance. That's important because it gives an operator a complete envelope to assemble an engine. These engines are more of a low volume, high variation. There's a lot of flexibility required. So each operator has a 17-inch monitor, and that monitor controls the assembly process. And if an assembly from one model to the next, which may be a different SKU, is not done in the right sequence, it will lock the operator out until a correction is made and the engine is made in the proper sequence. It's very state-of-the-art assembly process. We've got DC tools that come down and sequence assembly of the engine. Some of those are 17-spindle robot-operated DC tools. They make sure the sequence and the torque is done the same way, the right way, every time without fail. Here you see an example of one of those DC tools. This is a dual-spindle DC tools. It's a smart arm that positions that torque and that sequence. And it's a direct feedback to the main controller, so it records what's happening on every engine on its serial number for proper maintenance records. Mercury's 4.5-liter engine platform provides increased power and acceleration. It's lighter and more compact. It runs quieter and more smoothly. It's fuel efficient, it responds better, is the easiest to maintain, is more durable, and provides the best boating value and experience. This is a new product and a new direction for the industry. It is the first time that the industry has had a marine purpose-built stern drive and inboard engine platform, and we think it is a great step in the right direction in the new normal, which we are in now post global financial crisis.